Okay, this is part two of the midterm review, and we have just finished going over these problems here, and now we're doing the example midterm, and we're gonna try to continue here. So problem 8. For the following charts, state whether or not the process is in control or out of control, and describe why. Okay, if we go back to our study guide here, we're gonna use these four tests here. And so let's go back and apply each one. Okay, so the first one is we see that first of all, for test one, we see we have data points that are outside the control limits. We have three here at the upper control limit. We've got 1, 2, 3, 4, 5 at lower control limit. So it is out of control for that reason, and that reason. Now it's also, we notice there's other reasons it's out of control. It actually breaks the second rule, which is 8 or more points in a row above the mean or below the mean, and we see 1, 2, 3, 4, 5, 6, 7, 8. They're all above the mean. We actually have 9, 10, 11, 12, 13, 13, and then it also breaks. Let's check and see if it breaks the rule of having 8 or more below the mean. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it breaks that same rule again, having 8 data points below the mean. The third rule is whether you have 8 in a row in one direction or not, or in one direction or the other, either up or down. And we see that we aren't breaking that rule because we're pretty much, this is 1, 2, 3, 4, and then it starts to go back up again. So we aren't breaking this third rule, which is which is 8 or more points in a row in one direction. The fourth rule, though, cumulative above or below equal to 8. Yes, we are definitely breaking that rule too. Just the fact that the first 8 here are above, that it breaks that rule also for that reason, because they're all above. So we really don't need to count. We can see that there's a cumulative 8 above right off. Okay, so this process is out of control for 3 of the 4 rules, breaking 3 of the 4 rules, and it actually only has to break 1 rule for it to be out of control. Okay, let's look at this one. This process actually breaks all 4 rules, as we'll see. First of all, we see there's a data point below the lower control limit. That breaks rule number 1. We have 8 or more data points below the mean. We've got 1, 2, 3, 4, 8 or more data points in a row below the mean. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 below the mean. The third one is 8 data points in a row increasing. Yes, here we have 1, 2, 3, 4, 5, 6, 7, 8. And the fourth one here is cumulative data points both above or below the mean. So the way you can count this is by just keeping a running cumulative count, where you add 1 to your count if it's above the mean, and you subtract 1 from your count if it's below the mean. So if we start at 0 right here, we have -1, 0, -1, -2, -3, -4, -5, -6, -7, -6, -7, -8. There's -8. So at this point, we are out of control because we've got accumulation of 8 that are below the mean. Okay. So let's go to the next problem. Problem 10. A survey question asks recent graduates who uh, whether they are whether they were employed directly after graduation or not. The graduates are classified as either as to whether they now live on the mainland or live in Hawaii. State which table you are using. There's table 1 here, table 2 here, and table 3 here. So let's start with question 10. Use the results to figure out the probability that a graduate lives in Hawaii or is employed. Okay, so we can use table 3 for that because we can, since there's an or, what we're going to do is we're going to figure out the probability that a graduate lives in Hawaii, and then we're going to add to that the probability that the graduate is employed. But we're going to need to subtract out, though, from that sum, the probability that someone lives in Hawaii and is employed, because when we do this, when we add them, this value here actually gets added in twice. So the probability that somebody lives in Hawaii is 58% right here. 58%. We add to that the probability that somebody is employed, and that's right down here. That's 35% out of 100%. And then we need to subtract the probability that somebody is living in Hawaii and employed, which is this number right here, because this number is added to this probability, and it's also added to this probability here, and so it doesn't need to be added in twice. So this thing actually subtracts out one of them, and we end up with 58 plus 35% minus the 15%, and we get 78%. Okay. What's the next? If you know a graduate is employed, figure out the probability that they live on the mainland. So we can do that directly by looking at employed graduates here in table 1. These are all the employed graduates. Out of 100%, we see that 57% of them live on the mainland. Okay, that's a direct way to do it. The indirect way to do it, if you want to use the formula where the probability of somebody living on the mainland given that they are employed, is equal to the probability that they live on the mainland and they are employed divided by the probability that they're employed. And then with that you use table 3. So you would use this formula if you don't have a table 1. So that would be the probability that somebody lives on the mainland and is employed is right here, living on the mainland and employed, and you divide that by the probability that they're living on the mainland. They're living on the mainland and they are employed. No, you divide that by the probability that they're employed. So that the probability that they're employed is 35%. So mainland given they're employed is 20%, and just employed is 35%. So 20% divided by 35% gives you the same answer, 57%. Okay, 12. Write a sentence using the most appropriate of the 3 tables to discuss employment differences between residents who live on the mainland and Hawaii versus Hawaii. Okay, so I like table 2 for that, because table 2 gives us, of the 100% the people that are living in Hawaii, we see that 26% are employed and 74% are unemployed. So we've got about 3 times as many people unemployed as employed for folks that are now living in Hawaii. For the mainland, though, for those graduates who are living in the mainland, we see out of 100%, 47% are employed and 53% are not employed. So that's like almost, that's more like half. So in other words, that's what we see here. So in other words, 3 times as many people were unemployed as employed in Hawaii, whereas on the mainland it's about half. Okay, that's my sentence. The next 2 questions are, let's see. Annual income for a recent UH graduate follows a normal distribution with a mean of 45,000 and a standard deviation of 15,000. So, and we want to show our answers. So the first question is, what is the probability that a recent graduate's income will be outside the range of 26,000 to 66,000? Okay, so what we're talking about is a distribution that looks like this. And actually, I should have written it here, but this point, we want this point to be 26,000. This middle is going to be 45,000. That's what the mean is. And this line here, this threshold is going to be 66,000. So we've got 45,000 in the middle, 26,000 on the left, and 66,000 on the right. And we want to know what the probability is that you're going to land outside, either below this line, below this point, or above this point. The first thing we need to do is we need to calculate what these numbers are down here. I actually have them written here already, but these are actually the z-scores. This is the z-score for the 26,000, and this is the z-score for the 66,000, and 0, of course, is the z-score for 45,000 because that's the mean. So to compute the z-score, we need to use the formula, which is, I don't have the formula written here, but if we go back to the textbook, we see that it's on page 108, z-scores. So we're using this formula here, where x bar is going to be 45,000, s is going to be 15,000, and x is the score, the salary, which is going to be either 26,000 or 66,000 that we want to determine the z-score for. So if we go back to our test here, the z-score for 26,000 is 26 over 45 divided by 15. We can just use thousands here because the thousands will divide out. And that equals minus 1.267, which I put right here. So that means and then we need to convert, once we have the z-score of 1.267, minus 1.267, we can determine what the probability is, what the area is, the probability of being below that point. To do that, we go to page 521, and we find minus 1.26 works. Minus 1.2 minus 1.26 is this point right here, 0.1003, 1.2, oh, that's too high, 1.26 it's this column. Minus 1.26 is 10.38%. That's why we got 10.38%. Okay. So let's go back here, and so that would be 10.3%. So that is the probability of landing below 26,000. What's the probability of being above 66,000? Well, we got to figure out the z-score again, and it turns out it's 1.4. Let's go 66 minus 45 divided by 15 is about 1.4. And so let's figure out what the probability is for 1.4. We can go down to the positive area here, and we find 1.4, and it looks like it's 91.92%. 91.9%. Now we need to subtract that. 91% is to the left of 1.4 here. We actually want to do the opposite of to the left. We want to the right. So we just subtract 0.9192 from 1, and we get about 8.1%. So it'd be 0.0808 is what we get, I think. So that's 8.1%. So you add those two up, 10.3% on this side, 8.1% on this side, and the probability of being below 26,000 or above 66,000 is 18.4%. Okay, very good. Let's finish the next two, and then we can end this video and start again with part 3. Okay, the income what income would satisfy 90% of all recent graduates' incomes will be higher? Okay, draw a sketch. Okay, so we want the diagram to look like this, where we've got 90% higher. So we need to find this point. First we need to find this z by looking at the probability table we need to find this is 90% here. This is going to be 10% here on this side to the left. That's what the probabilities give us in the table. So we want to find what the z-score is for 10%. And so let's go to let's find 10%. That's up here. That's 0.1. That would be like right here, 0.1003. That's as good as it gets. That's minus 1.28. Minus 1.28. Okay, so let's go back to here, and so we've got, that's what this minus 1.28 is here. So that's the z, and then we have to convert the z to the actual salary, the mean and standard deviation that we're using. So we use that same z-score formula. We have x minus the mean divided by the standard deviation, and we solve for x. We start by multiplying both sides by 15,000, and then we can add 45,000 to each side, and we get 15,000 times minus 1.28, because we multiply both sides by 15,000, and then we add plus 45,000 because we've added 45,000 to both sides. That equals x. So now we just got to solve this equation for x. Multiply 15,000 by minus 1.28, which is a negative number, and then you add 45,000 to that, and you end up with 25,800. So that is the salary at which 90% of the people, 90% of the graduates' incomes is higher. Okay, the last question in this section is, would an annual income of $100,000 be considered an outlier? Well, let's just figure out what the z is for 100,000, and if the z is greater than 3 or less than minus 3, then it would be an outlier. That I'm referring to this formula here. If you go to page 108, a z-score that is less than minus 3 or greater than plus 3 indicates an outlier value. That's what I'm using here. So let's go back to here, and we can see that. Let's use the z formula. 100,000 minus 45,000 divided by 15,000 equals 55 over 15, which is 3.67, which is greater than 3. So yes, 300,000 or $100,000 salary would definitely be considered an outlier. Okay, I'm gonna end the video here, and we'll continue with question 16 with part 3. Thanks for watching.